Hi students, today's lesson is on percentages and their uses and abuses. There are three ways of using percentages. You can talk about them as a fraction, to describe change, or as a comparison. Example 1 says, an opinion poll finds that 64% of 1,069 people surveyed said that the president is doing a good job. How many said that the president is doing a good job? Well, we want to take 64% of, that's multiplication, 1,069. 64%, change that to a decimal, is 0.64. Multiplied by 1,069 is 684.16. Now, keep in mind you can't have 0.16 of a person, so we'll round down to 684 people. Absolute and relative change. The absolute change describes the actual increase or decrease from a reference value. So the new value minus the reference value, or sometimes the original value, is the absolute change. The relative change is a percent. That's the absolute change divided by the reference value. Sometimes I'll say new minus old over old. So new minus the original over the original. Or new minus reference over reference. Same thing. Okay? So example 2 says a diversified portfolio grows from $1,500 to $2,250. The absolute change would be the new value, that's $2,250, minus the old value, $1,500. $750. The relative change is that absolute change that we just found, 750, minus the reference value or the original value, 1,500. Multiply that by 100%, so it's a percentage, and we get 50%. So basically, the portfolio grew by 50%. You bought a computer 3 years ago for $1,000. Today it is worth only $300. Describe the absolute and relative change in the computer's value. So the new value here is $300, and the reference or original value was $1,000. So we get a negative number. We get negative $700. Well, you can't have a negative amount of money. So what we say is the computer has lost $700 in value. Lost is representing our negative. Then the relative change would be that negative 700 divided by the reference, that was the original, so 1,000, multiplying by 100%. And so that becomes negative 70%. Again, it's negative, so we say that the new worth is 70% less than what was paid. Absolute and relative difference are very similar to absolute and relative change. The absolute difference is the actual difference between the compared value and the reference value. So this time instead of changing from one quantity to another, we're comparing two quantities. So it's compared minus reference. And then the relative difference is compared minus reference over reference again. Always reference goes second and on the bottom. Average pay for full-time wage earners varies from state to state. Recent data showed that New York ranked first in average pay at about $60,300 per person, and South Dakota ranked last at $32,800 per person. Compare average pay in South Dakota to that in New York, both in absolute and relative terms. So the absolute difference is the compared minus the reference. We're usually comparing the second one, but if you focus on that last sentence, that will tell you. It says compare South Dakota to New York. So that means that your compared value is South Dakota, because it says compare South Dakota to New York. So the reference is New York. New York being 60,300 and South Dakota being 32,800. So we'll have 32,800 minus 60,300. Gives us negative 27,500. Again, you can't have a negative, so we need to put this in words. So we'll say that South Dakota's average pay is $27,500 less than New York's. And then the relative difference will be taking that number, the negative 27,500, and dividing by our reference, which was New York, 60,300, and multiplying by 100%. That gives us negative 45.6%. So we can say that South Dakota's pay is 45.6% less than New York's. Of versus more than. Sometimes these sound like they'd be the same thing, but they're not. So it's real important to be careful with this. If the new or compared value is p% more than the reference value, then it is 100 plus p% of the reference value. So, for example, if I make 50% more than you do, then I make 150% of what you do. So let's say if you made $100, if I made 50% more than you, and 50% of 100 is 50, I make $150. It's the same thing if I make 150% of what you make. 150% times 100 would be $150. Same thing if it's less than, but you would subtract when it's of the reference value. So let's look at an example to help explain that. Carol earns 50% more than William. How many times larger is her income than his? So remember, P% more than means 100 plus P% of. So we'll take 100 plus the 50%. So Carol's, make sure I say that, write that right. Carol's income is 150% of Williams. Or we can say Carol's income is 150% larger than Williams. Actually, no. It's times larger than Williams. Sorry about that. Times larger. Because it's 50% larger than, but 150 times larger. Could get rid of the percent. Okay? Example 6 says a store is having a 25% off sale. How does an item's sale price compare to its original price? Well, the sale price would be 100 minus 25% of the original price. So the sale price is 75% of the original price. When a change or difference is expressed in percentage points, assume is it an absolute change or difference. With the percent side or the word percent, it's a relative change or difference. So if it says a bank increases its interest rate from 3% to 4%, then it's increased by 1 percentage point. Okay, it hasn't increased by 1%, it's increased by 1 percentage point from 3 to 4. If we did the relative change, you would see from 3 to 4 means it increased by 33%. If the compared value is P more than the reference value, then the compared value is 100 plus P times the reference value. Or if you would need to find out the reference value and you've got the compared, you could divide. And if it's less than, you just use 100 minus P or 1 instead of 100 plus P. That should be a plus right there. You purchase a shirt with a labeled pre-tax price of $21. The local sales tax rate is 6%. What is your final cost, including tax? So you could find 6% of $21 and then add it on. That would be okay. Or you could say that the final cost is 100 plus 6% of the labeled price. So it would be 106% of $21, which as a decimal is 1.06. The price of the shirt is $22.26. That's the same as if we were to find 6% of 21 and add it on to 21. Beware of shifting reference values. Like if something says a 10% pay cut is followed by a 10% pay raise, you're not making the same amount of money. You're still making less. So be careful with that. If it said, what about something that's less than nothing? Decrease caloric intake by 150% to lose weight. Well, then that'd mean you'd have negative calories. Not possible. If 70% of the boys and 60% of girls in a class voted to go to a water park, you can't say that 65% voted to go to the water park. It depends on if there are the same number of boys and girls. So let's look at a couple examples of this. A stockbroker offers the following defense to angry investors. I admit that the value of your investments fell 60% during my first year on the job. This year, however, their value has increased by 75%, so you are now 15% ahead. Evaluate the stockbroker's defense. Well, it doesn't give you any numbers to start with, so let's just say that we're going to imagine that we invested $1,000, just because that's a nice round number to work with, okay? Well, if we reduced by 60%, then we would say 100 minus 60% times that $1,000. So your investment is now only worth $400 after the first year. But he comes back and says that it increased the next year by 75%. So 100 plus 75% times, we've got to times it by 400, not the 1,000, because 400 is what it is now before the 75% was added back on. So 175% of 400 is $700. As you can see, you are still $300 worse off than when you invested. You obviously did not gain 15%. In fact, you lost quite a bit. And then the last example says, in baseball, a player's batting average represents the percentage of at-bats in which he got a hit. For example, a batting average of .350, which I think is usually said batting average of 350, okay, means the player got a hit of 35% of the times he batted. Suppose the player had a batting average of 200 during the first half of the season and 400 during the second half of the season. Can we conclude that his batting average for the entire season was 300? Why or why not? Well, we don't have a lot of specifics here. We don't know how many games were played the first half or how many were played the second half. But we do know his batting average. So let's try to work out an example here that would make sense. Okay? I've done a little bit of research, and there are usually about 162 games per baseball season. Okay? And so that means in the first half, there would be 81 games. And in the second half, there would be 81 games. So that's equitable. That's all good. Except, is he necessarily going to bat the same each season? Is he necessarily going to go to bat the same? He didn't do too well the first part of the season, right? He only got a hit 20% of the time. That's not very good, which means it's likely that he's going to go to bat less times during the second half of the season. So we're just going to say that the first half of the season, he was a bat 360 times. With a batting average of 200. And we're going to say he only went to bat 290 times the second half of the season, because he did poor the first half, right? So he's going to be put farther down on the batting list. But he does better and gets 40% hits from the time he's at bat. So, the first half of the season, if he's at bat 360 times and 20% of those are hits, then he hits 72 times. And the second half of the season, if he's at bat 290 times and 40% of those are hits, then he gets 116 hits. So let's see what his batting average then would be for the season, or how many hits he would have for the season, and what his batting average would be. So 72 plus 116 means he gets a total of 188 hits in the entire season. How many times was he at bat? Well, he was at bat 360. Trying to find a different color. Plus 290 times. So 650 times at bat. So if we take his hits and divide by the number of times at bat, he gets a hit 28.92% of the season. So his batting average for the entire season is 0.289, not 0.300. Okay? So that's just a little example of why you can't necessarily average two averages. And that concludes our section for today.